The oil heat industry continually strives to improve the quality of the products and services we provide to our valued customers. We also know that energy conservation is one of our most important tasks. We have an obligation and a competitive need to help our customers reduce their fuel consumption and to get the most from every dollar they spend to keep their homes comfortable. One of the simplest ways to reduce fuel consumption is to upgrade older systems. Many homeowners have enjoyed savings of over 30% by upgrading to today's state-of-the-art oil heat equipment. Some have also added insulation, installed setback thermostats, and taken additional measures to make their homes as energy efficient as possible. This program will address another way to help your customers reduce their fuel consumption and lower their heating bills: the use of outdoor reset controls with hot water heating systems. But before we get to the specifics of how these controls can save energy, let's look at how conventional heating controls operate and how heating systems are designed. The temperature of hot water heating systems is maintained by limit controls that we commonly refer to as aquastats. An aquastat reacts to changes in the temperature of the boiler water by opening and closing switches that turn the burner on and off, ensuring that the boiler will be able to meet the heating and/or domestic hot water needs of the building while protecting the boiler against overheating. There are many different types of aquastats, and they don't all operate in the same manner. For this training module, we'll describe the operation of a common model. When the boiler water temperature rises to the set point that has been selected, typically around 180 degrees Fahrenheit, the electrical contacts of the aquastat open, opening the circuit and turning off the burner. When the boiler water temperature drops approximately 20 degrees below the set point, the contacts close again, turning the burner back on. Typically, when there is no call for heat, the aquastat maintains a boiler temperature of approximately 130 to 160 degrees. For systems that incorporate tankless coils, it's necessary to maintain a boiler temperature sufficient to ensure that the system can provide adequate domestic hot water. Aquastats allow our customers to enjoy both comfort and safety. They enable us to keep the boiler warm enough to supply heat, and in some cases, both heat and domestic hot water, while preventing the water from becoming dangerously hot. Heating systems are designed to provide adequate heat on the coldest days of the year. In any given geographic area, this is known as the outdoor design temperature. Boiler aquastats are set to provide a supply water temperature that will deliver sufficient heat on those very cold days. This is known as the supply design temperature and is typically 180 degrees or higher. Well, for example, a system installed in Bridgeport, Connecticut should be designed to adequately heat a home when it's 7 degrees outside. In other areas, design temperatures are similarly low. But this means that, by design, heating systems can supply much more heat than is needed most of the time. How many days out of a year is it down to only 7 degrees in Bridgeport? How many days is it at the design temperature in any of the locations? 10? 20? If there are 20 days that are that cold, then the typical heating system is configured to provide more heat than is necessary 94% of the time. Most people wouldn't leave the lights on in their homes for 94% of the time that they aren't needed, but it really isn't practical to expect customers to be willing or able to continually adjust their aquastats as outdoor temperatures change. But there is a way you can help customers with hot water systems to reduce both their energy consumption and their oil bills. Outdoor reset controls automatically adjust boiler water temperatures based on the outdoor air temperature, allowing the boiler to run at lower temperatures during most days of the year. Buildings lose temperature at a rate determined by the difference between the outdoor and indoor temperature. The colder it gets outside, the more heat is lost. The warmer it is outside, the less heat is lost. By matching the heat input to the building to the heat loss from the building, we can maintain a comfortable temperature indoors while using less fuel. Heat input is typically measured in British thermal units, BTUs. In a hot water heating system, the BTU input can be varied by adjusting the firing rate of the burner or by adjusting the temperature of the boiler water. Traditional hot water heating systems operate at high temperature all the time and regulate BTU input by starting and stopping circulator pumps and/or opening and closing zone valves. But this on-off method has some inherent disadvantages. Higher operating temperatures lead to more jacket, standby, and distribution heat loss, resulting in lower efficiency and higher fuel consumption. There are more temperature swings in the heated space due to intermittent flow at high temperature. There are also more expansion and contraction noises when intermittent flow is used to control temperature. Using outdoor reset technology addresses each of these problems. Varying the boiler supply temperature instead of interrupting the flow of constantly high temperature water provides a reduction in fuel use and causes smaller temperature swings in the heated space and less noise in the piping. With today's technology, we can use microprocessor controls that monitor the outdoor temperature and calculate appropriate boiler supply temperature to provide the correct heat input to the building. The outdoor reset control receives information about the outdoor temperature from an outdoor sensor and information about the boiler temperature from a boiler sensor. The location of these sensors is very important to ensure the control gets good information. The control is pre-programmed to follow a heating curve. The building's design conditions are programmed into the unit, and it follows this heating curve to calculate the boiler supply target temperature. The design conditions will vary from job to job and location to location, so the installer needs to know what the design conditions are to enter them into the control. The two most basic items are outdoor design temperature, typically the low temperature on the coldest day of the year, and boiler supply design temperature, the hottest water temperature required by that coldest day. Depending on the control, there may be other settings that can be programmed to match specific requirements. Well, for example, boiler minimum sets a limit on the low temperature. This is commonly used to make sure standard boilers do not condense. Terminal unit. Since the building's heat distribution system affects the heating curve, the type of distribution, also referred to as terminal units, is important. Typical outdoor reset controls have default settings for high mass radiant, low mass radiant, fan coil, fin tube convectors, radiators, and baseboard. These default settings can be changed based on specific job requirements. Indoor design temperature. The starting temperature for the heating curve, usually defaulted to 70 degrees Fahrenheit. Room occupied, unoccupied, allows the control to shift the heating curve up or down. Unoccupied allows you to use a lower heating curve if nighttime setback is desired. With all of this information, the control calculates an appropriate boiler supply target temperature to provide the correct BTU input to the building. It then operates the boiler to maintain this target, using, and with some units, adjusting a differential to help minimize short cycling and improve efficiency. Improper installation and operation of outdoor reset controls could result in damage to the customer's heating equipment and/or personal injury. Outdoor reset controls are not intended for use as the system's limit control and must not be used in place of an aquastat. Additional controls certified as safety limits must be in place in the control circuit. Always follow manufacturer's instructions and install controls in accordance with all applicable codes and standards. There are many brands and models of outdoor reset controls available on the market today. In this video, we'll examine the installation of a simple on-off boiler control that provides outdoor reset and domestic hot water operation. Step 1. Check to be sure that you have all the materials you'll need to complete the installation and carefully review the instructions that came with the control. Step 2. Install the outdoor sensor. The outdoor air sensor should be placed on an exterior north-facing wall, away from any potential source of heat. This will give the control the coldest ambient outdoor air temperature readings to ensure an adequate boiler target temperature. As a general rule, install the sensor where it will not be exposed to direct sunlight, away from window openings, dryer vents, exhaust vents, and boiler vents. Above the snow line, at least 24 inches above the ground, where rain or water will not affect it, in an area where it will not be subject to damage or tampering. Connect the required wiring to the sensor and run it back to the control according to the manufacturer's instructions. Although 18.2 AWG is all that is normally required, it is recommended that you use 18.4 wire to provide spares in case there's a problem with a wire in the future. Do not run the wiring close to any power, telephone, or data cables, which might cause interference. If the sensor wires are located in an area with strong sources of electromagnetic interference, shielded cables should be used, and the shield wire should be connected to the manufacturer's designated terminal on the control, not to earth ground. Step 3. Install the boiler sensor. The boiler supply sensor must accurately read the current temperature of the boiler. It can be located in a temperature well or strapped onto the piping. In some situations with larger steel piping, it is recommended that the sensor be installed in a temperature well instead of strapped to the pipe. As a general rule, the sensor should be installed on the boiler's riser before any takeoffs for zones or indirect water heaters. Make sure there is good contact between the sensor and the pipe and connect the required wiring to the sensor. If strapped to piping, it is good practice to insulate the sensor from cold drafts. Run the wiring to the control according to the manufacturer's instructions. Step 4. Optional. Mount an indoor sensor. The indoor sensor can be mounted directly on a wall or to an electrical box. Connect the required wiring to the sensor and run it back to the control according to the manufacturer's instructions. Step 5. Mount the control base. On this model, all wiring terminates in the control base wiring chamber. But before removing the knockouts, check the wiring diagram carefully and arrange for wiring with common voltages to be in the same sections. During the wiring process, do not allow the wiring to cross between sections, as this will interfere with safety devices which will be installed later to separate line and low voltage wires. Step 6. Electrical connections. Before making connections, mount the control to the base. For this model, push the control into the base and slide it down until it snaps firmly into place. To begin the input connections, connect a 120 VAC power supply to the power L and power N terminals. For the control we're using, that would be terminals 5 and 6. To generate a boiler demand, a voltage between 24 VAC and 240 VAC must be applied across the boiler demand terminals, terminals 1 and 2. We'll apply 24 VAC from the circulator relay end switch to the control. To generate a domestic hot water demand, a voltage between 24 VAC and 240 VAC must be applied across the DHW demand terminals, 3 and 4. we'll apply 24 VAC from the indirect water heater's aquastat to the control. Start the output connections by connecting one wire of the boiler pump circuit to the proper terminal, here terminal 7, and the second wire to the N or neutral terminal, 8. The domestic hot water or DHW pump valve contact terminals, 9 and 10, provide an isolated output for this control. There is no power available from the control, and these terminals are used as a switch to make or break power to the DHW pump or valve. We'll apply 24 VAC from a transformer through the aquastat to the control. Terminals 11 and 12 are used as a switch to make or break power to the burner. We'll apply 120 VAC from terminal 5 to terminal 11, which sends 120 VAC to terminal 12 to power the burner. Note, do not apply power to any of the sensor terminals, as this will damage the control. Connect the two wires from the outdoor sensor to the COM and outdoor terminals, 14 and 16. Connect the two wires from the boiler sensor to COM and boiler terminals, 14 and 15. Optional. Connect the two wires from the indoor sensor to the COM and indoor terminals, 17 and 18. Now that the wiring is complete, the control and boiler are ready to be put into service. It's good practice to verify the installation before putting the control into operation. Each terminal block must be unplugged from its header on the control before power is applied for testing. To remove a terminal block, pull it straight down from the control. A quality electrical test meter capable of reading from at least 0 to 300 VAC and at least 0 to 2 million ohms is essential to properly test the wiring and sensors. Before you begin testing the sensors, please note, do not apply voltage to a sensor at any time, as damage to the sensor may result. In order to test the sensors, the actual temperature at each sensor location must be measured. A good quality digital thermometer with a surface temperature probe is recommended for ease of use and accuracy. Where a digital thermometer is not available, a spare sensor can be strapped alongside the one to be tested, and the readings compared. First, measure the temperature using the thermometer, and then measure the resistance of the sensor at the control. The wires from the sensor must not be connected to the control while the test is performed. Using the chart supplied by the manufacturer, estimate the temperature measured by the sensor. The sensor and thermometer readings should be close. If the test meter reads a very high resistance, there may be a broken wire, a poor wiring connection, or a defective sensor. If the resistance is very low, the wiring may be shorted. There may be moisture in the sensor, or the sensor may be defective. In either case, to eliminate the wiring as a cause of any problem, measure the resistance directly at the sensor location. Before testing the power supply, make sure exposed wires and bare terminals are not in contact with other wires or grounded surfaces. Turn on the power and measure the voltage between the power L and power N terminals using an AC voltmeter. The reading should be between 108 and 132 VAC. Measure the voltage between the boiler demand terminals. When the boiler demand device calls for heat, you should measure between 20 and 260 VAC at the terminals. When it's not calling for heat, you should measure less than 5 VAC. During domestic hot water demand, the voltage between the DHW terminals should be between 20 and 260 VAC, and when there is no demand, it should be less than 5 VAC. If a domestic hot water pump or DHW valve is connected to the DHW pump valve terminals, make sure power to the pump or valve circuit is off and install a jumper between those terminals. When the DHW circuit is powered up, the DHW pump should operate, or the DHW valve should open completely. If either fails to work properly, check the wiring between the terminals and the pump or valve and refer to any installation or troubleshooting information supplied with these devices. If the DHW pump or valve operates properly, disconnect the power and remove the jumper. Use a similar procedure, power off, jumper connected, to test the burner. When the boiler circuit is powered up, the burner should fire. If the burner does not turn on, refer to any available installation or troubleshooting information. One common possibility is that the boiler may have a flow switch that prevents firing until the boiler pump is running. If the boiler operates properly, disconnect the power and remove the jumper. Reconnect the terminal blocks to the control by carefully aligning them with their respective headers on the control, and then pushing the terminal blocks into the headers. Before powering up the control, ensure that all power to the connected devices and terminal blocks is off, and any remaining jumpers are removed from the terminals. Before applying power to the control, you should turn down all thermostats and the DHW aquastat to prevent a call for heat. Install the supplied safety divider between the unpowered sensor inputs and the powered wiring chambers. Apply power to the control. The operation of the control on power-up is described in the sequence of operation supplied by the manufacturer. Dip switches allow flexibility in configuring the control for specific applications. They change the items that are available to be viewed and/or adjusted in the user interface. Dip switch settings should be made prior to making any adjustments to the control through the user interface. Be sure to read the manufacturer's instructions for the specific control you are working on. A number of options are available through dip switch settings on our sample control. They include the Advanced Installer dip switch is used to select which items are available to be viewed and/or adjusted in the user interface. The DHW valve DHW pump dip switch is used to select the type of device that is being used to control the flow of heat to the DHW tank. The DHW priority off dip switch is used to select DHW priority. The DHW during unoccupied off dip switch is used to select whether or not domestic hot water will be generated during the unoccupied or night period. If DHW during unoccupied is selected, DHW operates normally. If off is selected, a call for DHW during the night is ignored. The control has a digital display and buttons that allow for viewing of information and adjustment of settings. This interface provides simple observation, troubleshooting, and programming of the unit. The default display is the View menu, with the first item being the outdoor temperature display. Press the Item button to scroll to the next item. Observe the information provided, such as outdoor temperature readings, the boiler temperature measured by the boiler sensor, boiler target temperature, and symbols regarding current operation of domestic hot water pumps, boiler pumps, and the burner. Some items may not display depending on the access level, sensor inputs or settings, etc. Careful observation will help you understand how the system is working and assist in any troubleshooting. For example, if you see the burner symbol on the control screen and the boiler is not firing, then the problem is most likely with the burner or with the wiring between the control and the burner. The outdoor reset control we are using as an example has two main menus, Installer and Advanced. The installer menu requires minimal input and utilizes factory default settings that will work fine for most applications. The advanced menu allows fine-tuning of the control. To enter the installer programming mode, set the advanced installer dip switch to installer. Access the adjust menu by pressing and holding all three buttons simultaneously for 1 second. The display will then show the word adjust in the upper right corner. The room occupied adjustment is the first item displayed. Use the up or down button to set the room temperature. The room occupied setting is set to the desired room air temperature during the occupied day mode, typically 70 degrees. Next, press and release the item button to advance to the room unoccupied adjustment. Use the up or down button to set the room temperature desired during unoccupied or setback periods. For example, 65 degrees at nighttime. Then press and release the item button to advance to outdoor design adjustment and set the outdoor design temperature. Again, this is typically the coldest temperature of the year. Advancing to the terminal unit adjustment, select the desired terminal unit. The control manufacturer supplies numbers that correspond to the type of terminal that is being used. For example, radiators, fin tube convectors, fan coils, etc. Finally, to exit the Adjust menu, press and release the Item button until the display reads ESC. Then press either the up or down button, or simply wait 20 seconds, and the control will return to the View menu, showing the current outdoor temperature. This is the default display for the control. For most jobs, this will provide adequate information for the control to work properly. However, for some jobs, you may need to refine some of the settings in the Advanced Access mode. So you'll change the dip switch from Installer to Advanced. In addition to the settings made previously, you will also be able to vary the maximum boiler target temperature, the fire delay, the time delay between boiler contact closing and burner firing, automatic differential, the differential the control uses when operating the burner, the warm weather shutdown temperature during occupied and unoccupied periods, and the units of measurement. The control default is in degrees Fahrenheit. It can be switched to Celsius. The final screen allows you to exit the menu by pressing the up or down button. This control has a built-in test routine, which is used to test the main control functions. When the test button is pressed, the test light is turned on. The individual outputs and relays are tested in the following sequence: the boiler pump, the boiler contact, and the domestic hot water device. After the test sequence is completed, or if the test button isn't pushed for 5 minutes, the control resumes its normal operation. To simplify troubleshooting, the control will display an error message under certain circumstances. Once the situation that caused the error message to display has been corrected, the message can be cleared by pressing the Item button. Error message 1. The control was unable to read a piece of information. This can be caused by a noisy power source. The control will load the factory defaults and stop operation until all the settings are verified. Error message 2. This error is caused by an improper DHW dip switch setting. To clear the error message, set the DHW priority off dip switch to off and press the Item button. Outdoor sensor short. The control is no longer able to read the outdoor sensor due to a short circuit. Outdoor open. The control is no longer able to read the outdoor sensor due to an open circuit. In either case, the control assumes an outdoor temperature of 32 degrees Fahrenheit and continues operation. Locate and repair the problem per manufacturer's instructions. The boiler sensor circuit generates similar error messages if shorted or open. In either case, the control will not operate the boiler contact. Again, after fixing the problem, clear the error message with the Item button. With short or open errors in the indoor sensor circuit, The control will continue to operate as if there was no sensor connected. Repair and clear the error. However, if the indoor sensor was deliberately removed, the control must be powered down and then powered back up. When troubleshooting any heating system, it is always a good idea to follow an established routine. Here is an example of a sequence that can be used when diagnosing or troubleshooting problems in a hydronic heating system with an outdoor reset control. First, you must understand the problem. Get as much information from the customer as possible. Is there too much heat, not enough, or no heat? Is the problem only in one particular zone or area of the building? Or does the problem affect the entire system? Is it a consistent problem or only intermittent? How long has the problem existed? This kind of information is critical in correctly diagnosing the problem. A thorough understanding of the sequence of operation is also required. If a particular zone is not receiving enough heat, which pumps or valves in the system must operate in order to deliver heat to the affected zone? If the zone is receiving too much heat, what components must operate in order to stop the delivery of heat? One key to understanding the system is making a diagram of the piping. Often overlooked, this simple step can save hours of troubleshooting time. Note flow directions in the system, paying close attention to the location of pumps, check valves, pressure bypass valves, and mixing valves. Ensure correct flow direction on all components. Before making any adjustments to the control, make note of the items that the control is currently displaying. This includes error messages, current temperatures and settings, and which devices should be operating as indicated by the LCD. Press the test button on the control and follow the control through the test sequence. Pause the control as necessary to ensure that the correct device is operating as it should. Isolate the problem between the control and the system. Now that the sequence of operation is known and the system is sketched, is the control operating the proper pumps and valves at the correct times? Is the control receiving the correct signals from the system as to when it should be operating? Are the proper items selected in the menus of the control for the device that is to be operated? Test all contacts, voltages, sensors, and wiring to ensure that the control is receiving adequate voltage to the power terminals and the demand terminals as noted in the technical data. Common problems with outdoor reset installations are incorrect wiring, most often not supplying voltage to the boiler demand circuit. Poor sensor location. If sensors are in a poor location, then the control gets poor input and will provide poor output. And improper programming of the settings to match the specific job or location. These include outdoor design temperature, boiler design temperature, and the type of terminal units used. There are significant advantages to constantly matching the operation of the boiler to the outside temperature. More efficient operation leads to lower fuel usage and less environmental impact. More stable indoor temperature leads to happier customers and less chance of excess thermostat adjustments. More even supply temperature and more constant flow result in a reduction in noise caused by expansion and contraction of piping, providing a quieter living environment. Combining optional features into the control can provide even more benefits for the customer. Warm weather shutdown can automatically shut off heating during warm weather. Smart domestic hot water operation provides priority over heating zones and allows the boiler to run hotter during a DHW call. It also allows DHW operation if the system is in warm weather shutdown. Pump purging allows the circulator pump to operate for a time after the call for heat has been satisfied. This makes use of residual heat from the boiler, which would otherwise be lost. Indoor feedback using an indoor sensor provides the most accurate supply target temperature to the control, enabling it to fine-tune the supply water temperature. With outdoor reset control, efficiency increases from 5 to 15% are common, and there have been some installations where substantially higher energy savings have been reported. This is technology that has been thoroughly proven in commercial installations and, with the increasing cost of energy, is now an important option for residential systems. And please remember, when you completed the installation, clean up the work area, advise the customer how the control operates, and leave the instructions in a convenient location for use by technicians in the future. When you consider all the benefits, comfort, reliability, and efficiency, an outdoor reset control is a wise investment for almost every customer whose home is heated by a hot water heating system.